This video is about project evaluation review technique that's also called as PERT. It is an essential part of project management. In project management, we have to deal with many type of activities. Consider that you are building your house, starting from buying land and then starting construction, setting up lawn for your house, painting your house, buying furniture and moving in. But you can see that some activities they can only be started once a particular activity is finished. For example, painting your house. You cannot paint your house unless construction is finished. Similarly, you cannot move in furniture or you cannot move in your family unless everything is finished. In project management, we want to organize all these things. In this table, there are different activities. For example, a list of activities for the Western Hills Shopping Center project. Activity A is about prepare architectural drawing, and this is the first activity. There is no immediate predecessor before that, and it takes about 5 weeks. Then there is activity B that's about identify potential new tenants. Again, it starts and therefore there is no predecessor, and this activity takes 6 weeks time. Then activity C is about developing prospectus for tenants. Its immediate predecessor is A, which means this can only be started once activity A finishes. So you can also read it this way, that activity A leads to activity C. Then activity D, that is select contractor, and its predecessor is A. Again, you can read it backward. You can say A leads to D. Then activity A E is about prepare building permits, and its immediate predecessor is A, or A also leads to E. And then F, obtain approval for building permits, its predecessor is E. And activity G, that's perform construction, its immediate predecessors are D and F, and it takes 14 weeks. Now, which means that this activity construction, it cannot be started unless activity D and F, they are finished. So D and F, they lead to G. Similarly, we have activity H, that's finalized contracts with tenants. That takes 12 weeks. And the last activity is tenants move in, and its predecessors are G and H. In other words, G and H, they lead to activity I, and this activity, tenants move in, it takes 2 weeks. And the total time for the project is 51 weeks. Now, the first step when we want to use this technique, that's project evaluation review technique, the first thing is that identify new activities, identify activities and note the time. Okay, we have all these activities and we also know the time it takes, and we also identify their predecessors. Now, in the next step, we'll convert this data into a network diagram. And that network diagram is here, this one. This is a network diagram. And in this network diagram, this is start. And after that, there's activity A and then B. And A leads to E, D, and C, which means once activity A is finished, you are done with prepared drawings, then you can proceed to prepare permits and select contractors and develop prospectus. And then E leads to F. And for activity G, D and F must be completed because you can see these arrows. This arrow is coming from F and also from D. So which means activity G can only be started once activity D and F both are finished. If only one of these activities is finished, for example, let's say if only D is finished, but F is not finished, you cannot start activity G. Similarly, if only activity F is finished, but D is not finished, again, you cannot start activity G. So activity G can only be started once both D and F are completed. Similarly, we have this activity, that's H, that's finalized tenant contracts. And this activity can only be started once activity C and B both are completed. If only one of them is completed, you cannot start activity H. Then activity H leads to I, leads to finish point. Now, in the next step, we want to add our time into this one. And for this purpose, we will convert these cells into this format, whereby this cell is split into four subcells. Here we write activity, and here we write the time it takes to complete that activity. And then there will be one cell here and one cell here. We will be filling them in the next step. So for example, if we talk about activity A takes 5 weeks. Let's check it from our data. Activity A takes 5 weeks. Similarly, activity B, it takes 6 weeks. So activity B, it takes 6 weeks. In the next step, we will be filling out this one. Let's start with this one. So for example, now start activity A. Now activity A, it starts at what time? Of course, every activity will start at 0 time. And then how much time this activity A takes to complete? It takes 5. So 0 plus 5 is equal to 5. So we will write here 5. So which means that this activity, the earliest time it can start is 0 and the earliest time it can finish is 5. Similarly, if we talk about this activity B, when does this activity start? This activity starts at 0 time and then it takes 6 weeks. So which means this activity will finish after 6 weeks. So I write here 6, which means 0 plus 6. Activity E, D, and C, they emanate from activity E, which means they can only be started once activity A is finished, and activity A finishes on 5 weeks. So, which means activity E will start in week 5. Activity D will also start from week 5, and activity C will also start from week 5. So in other words, this 5, it has been transferred here, here, and here, because these three activities, E, D, and C, they are emanating from activity A. So this 5 is transferred here, here, and here. Okay. Now activity E starts in week 5 and it takes 1 week. So what time it will finish? 5 plus 1 is 6. So activity E will finish in week 6. What about activity D? It starts in week 5 and then it takes 3 weeks. So it will finish by week 8. And this one, that's 5 and 4, which mean activity C, it starts after week 5 and then it takes 4 weeks. 5 plus 4 is equal to 9. Now we will repeat this pattern in the other one. Now activity F. Activity F is arising from activity E. So which means this 6 will be transferred here. 6 plus 4 is equal to 10. So 10 comes here. Activity G is coming from F and D, which means activity G can only be started once D and F are finished. Now, what I should transfer here? Should I transfer 8 or should I transfer 10? I must transfer here only 10. And the reason is that because this activity, it cannot start unless activity F is finished. So imagine you are done with activity D, which was finished by the end of week 8. But you cannot start G because G requires F to be completed and F is going to finish by week 10. So therefore, you must wait for week 10. Therefore, I will transfer this 10 here because it can only start in week 10. Although one of the activity D, it finished earlier. So remember this rule. Whenever an activity is emanating from two activities or multiple activities, we will choose the bigger number. So here we had two options. We had one option 10 and other option is 8. And which one is bigger? 10. So we will move 10 here. And we will also use the same logic here for activity H. Now, for activity H, we know activity H can only be started once activity C and B are finished. Now, B is finishing by week 6, but C is finishing by week 9. So, which means we cannot start activity H unless activity C also finishes. So, which means even when B is finished by week 6, we need to wait up to week 9 unless this activity finishes. Or, in other words, just using the simple rule, which one is larger? Is 9 larger or 6 larger? 9. So I will transfer 9 here. Now the next step is that this activity starts in week 9 and it takes 12 weeks. So which means 9 plus 12 is equal to 21. 21 will come here. And same thing here. Activity G starts by week 10 and it takes 14 weeks. 10 plus 14 will be 24. 24 will be here. Now again using the same logic. Now this activity I, it cannot be started unless activity G and H both are finished. So again, what we will write here? 21 or 24? Of course 24, because 24 is bigger than 21. So I will write here 24, which comes from activity G, and then it takes 2 weeks. So activity I, it starts in week 24 and it takes 2 weeks. So it means the time will be 26. And now we can say that this whole project, it will take 26 weeks. Now we are done with one part in which we were moving from left to right. So as you can see that in this part, we were moving from left to right. That was our direction. We also need to fill these cells, the lower cells, and for that we need to move in the reverse direction, which means moving from right to left. Now in this part, I'll be moving from this to this direction, from right to left direction. And for that, this 26, which is the last activity, it will be transferred here at 26. And then 26 minus 2 is 24. So I will write here 24. Now again, rule here is when we will be doing it, we will be subtracting 26 minus 2. When we were going forward, we were adding 24 plus 2 is becomes 26. When we are going backward, we will be doing everything exactly the opposite. So there it was 2 plus 24 is equal to 6, and now it will be 26 minus 2 is equal to 24, and I will write here 24. Okay, we have here 24. It's straightforward. This 24 will be moved here. It's also moved here. 24 minus 14 is equal to 10. 10 will be here. And 24 minus 12 is equal to 12. 12 will be here. Now, this 10, it will be transferred here and here. Okay. This 10 transferred here. 10 minus 4 is equal to 6. And this 10, when it transfers here, this becomes 10. And then 10 minus 3 is equal to 7. Now here we have 12, and this 12, it will be transferred here and here. 12 minus 4 is equal to 8, and this 12, when it comes here, 12 minus 6 is equal to 6. And similarly, this one, this is 6. This will be transferred here, 6. And 6 minus 1 is equal to 5. Now the last one is filling this A. Now the question is that what I should write here at this place? I mean, should I write here 5, 7, or 8? Well, as I mentioned earlier, that we'll be doing exactly the opposite. You know, when we were going forward, the rule was that the bigger one, we choose the bigger one. And when going backward, which we are doing right now, we will choose the lower one. So 5, 7, and 8. Out of these three options, which one is smaller? 5. 5 is smaller. So I will transfer this 5 here. So you see, my approach has been exactly the opposite. And 5 minus 5 is equal to 0. And we are done with this one. This one is called as earliest start time, which means activity E, the earliest time it can start is 5. and the earliest time it can finish is 6, and this is the latest time, start time. The latest it can start is 5, and the latest it can finish is 6. Now you can observe here something. For example, here 0 0, 5 5 5 5 6 6 6 6 10 10. That in many of the cells, the values in the upper cell and the lower cell, they are the same. Similarly, for example, we can also see here 24 and 24, 26 and 26, 10 and 10, and 24 and 24. So in some of the cells, upper values and lower values, they are the same. But in many other cells, or at least in some cells, they are not the same. So for example, in activity D, we have 5 and this is 7, and there's a difference of 2. Similarly, here it's 8 and this is 10, which is difference of 2. This is 5, this is 8, there is a difference of 3. And then this is 9 and 12, again, there is a difference of 3. Similarly, we can also see a difference of 3 in 9 and 12, and difference of 3 in 21 and 24. We do not have any slack here. For example, the earliest time this activity can start is 5, and the latest time it can start is also 5. Earliest time it can finish is 6, and the latest time it can finish is also 6, which means we do not have any slack here, which means it's a critical activity because we do not have any available time here, slack here. But on the other hand, consider this one, consider activity D. Activity D, it starts at 5 and it finishes at 8, and the latest time it can start is 7, and then it will finish at 10. So which means here we have some slack of 2 hours. In this one, do we have any slack? No, because the difference of 10 and 10 and 24 and 24 is 0. So we have some slack here in this activity. We have some slack here in this one, some slack here in this one, and also some slack here. Now, for example, activity B, this activity starts at 0 and finishes at 6. But the latest time it can start is 6 and 12, which means this activity, although it's normally supposed to start at 0, you can also delay it or postpone it to week number 6, and it will not affect your schedule. This is a critical activity because we don't have any slack here. This is a E is a critical activity because we do not have any slack here. F is a critical activity again because we do not have any slack here. G is a critical activity because we do not have any slack. I is a critical activity because we do not have any slack. So you can see that the critical path is this one: A, E, F, G, and H. So this is the critical path, which means we cannot afford to delay these activities, because if something happens in these activity, it will affect the whole project. But we have some slack here, which means we can delay it and it won't affect the project. This is also not a critical activity. You can delay it, it will not affect the project. This is also not a critical activity. You can delay it and it will not affect the project. For example, this activity, as you can see, activity H starts at 9 and it finishes in week 21. The latest time when it can finish without affecting the project is 24, which means you can delay this activity, or at least you have a slack here of 3 weeks. So this is not a critical activity. Now, then we make a table, and in that table, again, we subtract EF, that's earliest finish time and latest finish time. So 5 minus 5 is 0. Activities B, C, D, and H. So this activity has some slack, D activity has slack, C has slack, and H has slack. So B, C, D, and H, these are 3 activities that have slack, which mean they can be delayed and your project will not be affected. So this is B, C, D, they have slack, and activity H, it has slack. All other activities, This one activity A, how much slack it has? Zero. So therefore, it's a critical activity, which means you cannot afford to delay it. E, F, and G, how much slack they have? These three activities, they have zero slack, which means you cannot afford to delay them, and therefore they are critical activities. And the same thing is with I. How much slack we have here? Zero, and therefore that's also a critical activity. So this is project evaluation review technique, which is a part of project management. And the advantage of this is that we can determine that which activities are critical and which activities are not critical. So, for example, in this case, that you can delay this activity, which means it's not a critical activity. So, but on the other hand, E is critical activity, F is critical activity, G and I are critical activity. So you may wish to transfer some of your resources from either C, D, B, or H to E, F, and G so that these activities are completed in time because they have some slack. You don't have to worry much about that because some time is available here in C, D, H, and B. Therefore, one of the lesson of this technique is that you can channel your resources.